Okay, this is the cylindrical tank for response, 95AB5. Okay, it gives you a picture of the volume, water in this cone leaking into a tank. And it tells you the height of the tank, the diameter, the area of the base, and it tells you the depth, which is h, in feet of the conical tank is changing at a rate of h minus 12 feet per minute. So this is the rate in the change in the height. So dH dt is h minus 12. Okay, first question. Write an expression for the volume of the water in the conical tank as a function of h. So the conical tank is this cone right here. So I know the equation, general equation is pi r squared h, but they want it as a function of h. So what that means is I only want h in my equation. So somehow you have to get rid of this r. Well, this is, we're going to set up a proportion again. So if you look at your picture, okay, you can draw similar triangles, and the relationship is that the radius is to the height is to 1 is to 3, right? So because the diameter is 8, that means the radius is 4. So the general radius we call r, here's h. The relationship between the radius height is 4 to 12, and I just simplified it to 1 to 3. So if I solve this for r, I get that radius is always 1/3 of the height. So I'm going to take this and substitute in here, so I get rid of the r variable. So I get v equals 1/3 pi h over 3 squared times h. So at this point you're done. This is an expression for volume in terms of h. I'm just going to clean this up a little bit, so you can also have this. Okay. Part B, at what rate is the volume of the water in the conical tank changing when h is equal to 3? So they want to find dV dt when h is equal to 3. Okay, I'm going to start with the equation that I have from part A. I need V, and I know dH dt is what you're given, so I'm going to go ahead and just take the derivative of this. dV dt equals, bring down the 3, keep the 27, keep the pi, reduce the power by 1 times dH dt. And dH dt was h minus 12, so I want to know what h is equal to 3, so dH dt at that moment in time is going to be -9, so that's what I'm going to use right here. And h is 3, so I'm just going to plug and chug, so dV dt ends up being -9 pi feet cubed per minute. And we're talking about the change in volume of this cone, of the conical tank, and it makes sense that your dV dt is negative because the water is leaking out of this cone. Okay? Last part, let y be the depth in feet of the water in the cylindrical tank. So y is this height right here. This is the depth of the water. At what rate is y changing when h is equal to 3? So in this part, they want you to find dy dt, which is really the height of the cylindrical tank, when h is equal to 3. Okay, again, same idea. But now I need a volume of the equation of the cylindrical tank. I need a y in there. Okay, they gave you that, if you look up here, the tank has a base of 400 pi. So what they're telling you is that the base of this is 400 pi, so they've already given you the base. How do you find the volume of something? It is the area of the base times the height. So the volume of the cylindrical tank is 400 pi times y. Okay. I'm going to take this derivative with respect to t, dV dt is equal to 400 pi dy dt. Now, y is what I'm looking for. This piece right here, you are actually given this value from part B. The volume on this cylindrical tank is increasing because the water is coming in, but the volume of the water that's changing here is the same amount of water that's coming out of here. So in part B, we figured out that dV dt is -9 pi. That's how much water, the rate at which the volume of this is changing. But since that water is coming into here, this water level is increasing, so I want to use that +9 pi for the dV dt here, and then plug and chug, solve for dy dt. I get 9 over 400 feet per minute.